derivation for torque experienced by a dipole in a uniform electric field. Torque experienced by a dipole in an uniform electric field. So consider a dipole with charge q, separation 2a, and dipole moment p. Making the figure, this is a uniform electric field. And uniform electric field, we know the direction of the electric field is from positive to negative. We will consider a dipole plus q charge minus q charge at an angle theta to that of electric field. So, making an angle theta with the electric field. So the force experienced by the charge at q, that is point B plus q, will be towards this direction, FB, and due to the charge at A, that is minus q, it will be towards this direction, that is FA. And as we know, this is the distance 2a, and this will be the perpendicular distance between the two charges. So this perpendicular distance will be equal to 2a sine theta. Now, the force experienced by charge minus q will be equal to FA is equals to Q into electric field, but the force is along the field. Sorry, the force experienced by charge plus Q, that is this charge, is directed towards this direction, that is along the field. Force experienced by charge minus Q, that is this, is against the electric field. So F A is equals to QE, this is FB, it is against the field. As we know, both the charges are equal and opposite, so they cancel each other. Both the forces are equal and opposite, so net force is equals to 0. Hence, no translatory motion. But the forces form a couple. Forces form a couple. Hence, torque is experienced by the dipole. Hence, torque. Torque is equals to force into perpendicular distance between the charges. We know the force is equals to QE and the perpendicular distance is equals to 2a sine theta, which we found out above. That is here. So, we'll take E sine theta together and write 2a into q. And we know 2a into q is dipole moment. So it is QE sine theta. So torque is equals to, sorry, this is P, dipole moment. Torque is equals to P cross E, the cross product of the dipole moment and the electric field. Because we know the cross product of two values gives us multiplied into theta. A cross B gives us AB sine theta. So P cross E will give us PE sine theta. So now we'll get on to the special cases, where the first case is if theta is equals to 0. It is a case of stable equilibrium. Then torque is equals to PE sine 0, which is equals to 0. Second case, when theta is equals to 180, the equilibrium becomes unstable. So the torque becomes PE sine 180, which is also equals to 0. Third case, when theta is equals to 90 degree, torque is equals to PE sine 90, which is equals to PE. So torque is maximum when theta is equals to 90. This was the derivation for torque experienced by a dipole in a uniform electric field. Thank you. I'll see you in the next video.